the purpose of this talk is to talk about advanced threat that we see and the security. So I'm Mohamed Kerroumi. I work at Zimperium for the past 7 years now, and basically I help developers like you to use our product and protect their mobile apps, right? So we work with customers in the banking space, automotive, lots of customers who try to protect their app. And in this talk, we'll be covering some of the threats like static and dynamic threats. I will go into details, and I also have a demo that I will be showing you how we can reverse engineer an application. And we will see as well the best practices and the solution that exists to protect the apps, right? So this is a little bit about myself. I started as a pen tester. In fact, it was by chance. It was my first experience. I started with a French company. It's called Alcatel. And we started in this phone that you see here, it's a voice over IP phone. And my first role was to try to break into this phone, try to find vulnerabilities. And we managed basically to extract the audio communication by decrypting the data because the key wasn't clear in the network. So it means that anyone could basically have access to the communication in the network. So as you probably know, if you have access to the key, you have access to the data, you have access to everything. And it's still true, even after 20 years now, it's still true on mobile devices, right? So, but now you don't even need internet cable. You just have, if you have access to the mobile device, either if the device is rooted or if the device there is a malware, there are some data, some useful data that you can get from exfiltrate from the device, right? So basically, in mobile devices right now, we use it to do everything from payment to work, messaging, traveling. We use our phone every day, and we are always connected. So we need to understand that the app itself is connected to the backend. So there are some API keys, there are some secrets inside the app, there are some certificates, and we need to make sure that those are protected and they are not visible at the first place when we do the reverse engineering, and the second place when the application is being tampered at runtime. This is what we call runtime attacks. So the apps are being targeted because they are an easy target and they access everything and they are always connected to the backend, right? And we do have some numbers, basically because at Zimperium, we work with Google, and every app that gets pushed into the Google Play, it gets analyzed by our engine, and we kind of know what's going on in the field. And you can see here some big number that almost 82% of the app doesn't have proper protection against static attacks. So they don't have advanced obfuscation and advanced technique to protect them from attacks. So basically anyone can get your app, analyze it, decompile the code, and understand and get some secrets from the application, or either it can just copy the code and create a clone of the application, right? So every time I come to this event, droidcon, I ask people, they say, oh, okay, I'm using ProGuard or R8, my app is obfuscated, is kind of protected. So ProGuard R8 is a good first step. It's better than nothing, but we can do much better than this, and I will show you the other techniques that can be useful to protect your apps. The second number I have is also almost 82%, which is the no on-device protection. So applications, can run into a can run into a routed device. There's a huge number of routed devices out there. And basically, on a routed device, everything is open. So you can see the file system, you can see everything that you store, for example, in the share preferences or your SQLite database. This can be easily extracted from a routed device. And you can also have access with instrumentation to the memory. So you can instrument, modify the application at runtime, and inspect all the data. So there are also people, for example, that use your app, that use apps on emulator to spoof the camera. For example, when you do the authentication and you need to prove that your identity, basically, they can spoof the camera on emulator. So it's really important to protect against this type of threats. And the last one is the data protection and key protection. So key protection, this is coming back to my first story. We need to know where our keys are stored. Are they hard-coded in the code? Are they somewhere in the configuration? So we need to make sure that the keys are properly protected. Otherwise, someone can get the key and then decrypt all the data that goes with it, right? So now let's start for the type of attacks. I will categorize them in two parts. So they are like the static one and the dynamic runtime attacks, right? So for the static attacks, this is when you develop your app, you push it on the store, it's released, then you don't have any control. You don't know who is downloading your app, what they can do with it, and you will see the type of attacks that can happen just by doing static analysis of the app. So it means that I can take your app, analyze it, and can repackage it, create a modified application. It can be useful for example, bypassing any premium subscription or removing the ads. And there are tools out there that do this even automatically. So we need to make sure that when we are developing our app to store securely our API keys, because they can communicate with the backend, and make sure that we have a proper protection for this against this type of static attacks. Right? So here we can see, there is I just took a random website, a screenshot of a random website where we see some apps there, and anyone can basically download for free a modified application that bypass the premium subscription or the ads. So there is the easy way where you can have tools like framework tools. It's called App Patcher, who patch the app. You just choose what you want to do in terms of patching. For example, you can remove the license verification. You can remove the Google Ads. So if your app is relying on ad revenue, this can be a loss for you because someone can just get it for free. And the other thing is the advanced way where an attacker will be motivated to attack your application. So he will try to find the vulnerabilities there, make the right modification after decompiling, and then rebuilding and repackaging a new version. So let's have a look to a demo. I will show you a demo how it's easy it can be to do a static analysis of an app. So 1 second here. All right. So I have chosen like an open source app. It's called Root Beer, and it has, maybe some of you use it already to detect root into the app. So it's open source, so we're gonna check it here. So I'm using a utility tool, and we can just drag and drop. You can see the app here. And it takes just a few seconds to get access to the code of the APK file. So yeah, it's done. So you can see here we'll just make it bigger for you guys to see. So what we can do with this, basically we can go into the classes. We can check, for example, the main activity here. And we can see all the code. I don't know if you can see clearly, but we can see the strings, we can see the code, the method, because there's no obfuscation here. And what we can do as well is we can search for anything useful. For example, if I type, if I go to the resources, API keys, yeah, so you can see, for example, this is just an example that I put here, but if the keys are inside your resources, you can easily find them by just searching anything useful. You can search for keys, you can search for encryption, decryption, whatever can be useful for you to access. So in general, the resources, we see a lot of sensitive information in the assets folder. For example, here, there could be some configuration, also some config files that can contain some useful information, or even some hard-coded keys that we have seen in some apps in the code, right? So now I'm going to show you the same thing, but with a protected app with R8, right? So just close this one. And we will see basically the difference between R8 and the non-obfuscated version. So if you can see here, there is some modification. There is some letters and numbers instead of the names of the classes and methods, because what R8 or ProGuard does is class renaming. So it also does optimization and a lot of things, code shrinking, etc. But the main thing, what they call obfuscation, is class renaming. So it means that the code itself, as you can see in the main activity, is still visible. There is no obfuscation in the code. There's just the name of the classes. But an attacker basically can still see all the strings and understand what the code is doing, even if the names have changed, right? So that's about what R8 and ProGuard are providing. But I want to show you now the version where we have protected the app with the stronger tools, commercial grade tools, I would say. So this is the protected version here. Yes. Sorry. So I will also open the other one, the previous one, so we can see a view of the differences between the non-protected version and the protected version, right? I'll just make this here, this here. So the first thing that we see in the protected version is that the code for the main activity is not here anymore, right? So there's no classes that are visible, because what we do is we convert the Java to native. So we create a new library and we protect this library, right? So all the code that you select to protect will be moved into this new library that you see on the bottom, like here. And all the code is protected inside this library. So it's native code and it's also obfuscated. There are other tools that we can use to protect, to decompile, I would say, native code. I do have one here, I will show you later, just to show you what it looks like. But the general idea is that all the code has been protected. It's not visible like here anymore. So it's good, for example, to use, as you can see, we don't modify the classes, we don't rename the classes, because it's not really our job. We know that R8 and ProGuard also doing this. What we do is complementary. We add more protection in terms of code, and we will also add other techniques. I will explain them later, like integrity checking and resource encryption. Because if we look now into the resources, which is here, so this is the config.json. This is what it was before, and this is what it looks like now. So basically what we have done is we have encrypted the resources to make sure that, you know, someone who tries to understand what's inside the resources, he cannot see anything. it's encrypted. So the resources are encrypted. We encrypt as well the DEX file. So if we try to decompile it, it will be very hard to do it. That's the only thing that we see. So one thing I want to show you as well in the demo is how we can decompile a native library, native code, because some people also develop in native C, C++ code as a library. We do have an example here in the lib folder for root beer. They have something called libtoolchecker.so file. And I have another tool that can decompile this. So if I open it, we can see, as well, we can see all the strings. And we can also see, so like here, this is where we do the check for binary. And if I click on the functions, I can, here. So this is what it looks like. So it's not really complicated to understand the code that we see here. And we can navigate and see, every time we are doing some file open, etc., and some printing. So that's a library that is not protected. So let's see now the one that's being protected, which is here. So I will do the same thing and search for the strings. So the protection itself, you see there's no real string because it will be randomized. And there's nothing useful that you can find here. And even the code itself is not visible. There will be a lot of. We just open one of. Yes, you can see here. Yeah. So we make things basically harder to understand. And let's come back now to the presentation. And I will summarize basically the techniques that we have compared to R8 and ProGuard. And by the way, if you are developing in framework like Cordova or anything that has that will generate JavaScript, the JavaScript itself will be inside the asset resources folder. So anyone can just also go to the asset and find the JavaScript code. There's no really protection. So it's really important to have this encryption for the resources if you are running into hybrid apps. So you can see here with R8, we do class method renaming. That's the main thing about the obfuscation. The other things are about shrinking, optimization, things like that. But there are much more that we can do in terms of protection. One of the main things is to prevent, for example, the example before, which is the repackaging of the application. So you need to have protection against repackaging. Someone take your app, repackage it, create new one, or clone it. And you can also need to have integrity checks. So make sure that your app has the integrity protection from tampering at runtime. So it means that your code basically will not be modified, and you are sure it has some checks and cannot be modified. The other techniques are, code and data protection. Make sure that all the strings are not visible; they are protected. No string is available, and also control flow obfuscation. This is a technique where we, change the control flow of the code of the functions to make it difficult to reverse engineer. And we also add, for example, some junk code and techniques like that to make it harder to understand for an attacker. So this is all about static attacks. So we have seen static attacks. Now we are going to move into dynamic attacks. This is basically when you have access to the application and you run the application into a device or emulator, and then you can control the behavior and you can manipulate. It's almost like you are debugging the app in real time. So the same as you do in a debugger, you can put breakpoint, etc. You can access the memory, you can change the memory on the fly at runtime. So if there is, for example, an application that is doing, authentication, or you can bypass some of the things. Even the SSL certificate pinning can be bypassed if you have like routine detection. This also can be bypassed by using instrumentation tool or hooking tools. So let's talk now about one of the most popular tools. So we'll be covering like routine first, and after we'll be talking about instrumentation. So there is a company, a fintech company, who reached out to us recently, and they failed the pen test because they were using some custom root detection. So they used root beer and they modified to add more checks. And they failed the pen test. They integrated play integrity, and they failed again the pen test. So the reason why they were failing is because the pen test company was using Magisk, which is a very popular tool for routine. And Magisk has been here for a while, maybe 8 years now. And it gets on getting more and more, I would say there's a great community who are developing Magisk and following up and evolving it. There's almost like 300 people who are contributor and working on Magisk. This is without counting all the versions and what we call the fork of Magisk. So we have, for example, Magisk Delta, Alpha, Canary, and Magisk is great because it's like a framework when you can have modules, and all these modules can help you to bypass the routine and also to fix the play integrity, because the motivation behind Magisk is mainly to have the people who root their device to be able to have, their banking app that is running, to have everything in there, like even it's like the device is not rooted. So it's used what we call, systemless technique. It means that before Magisk, all the tools were modifying the system partition, but Magisk will just modify the boot partition, and it will keep the system partition like it is. So it's very useful. And the main thing as well is the ability to bypass the routine for specific apps. So I have an example here that show you. We have like the app that can detect routine on the left, and then in Magisk you just select the app that you want to add to bypass the root, and then you can see that the app will just think that the device is not rooted, right? So why I'm telling you this about routing, because as you know, on a rooted device, you have access, or an attacker who is running your app inside a rooted device, he has access to everything. He can see the file system, he can access the memory, and you need to, when you build your application, you need to make sure that this case is handled. There's no sensitive data in your app, in your shared preferences, or anything specific stored in the file system can be accessible. For example, if there is a messaging app, we know some of the chat histories or anything related can be stored in SQLite databases, and on a rooted device you can easily extract this and read it. So it's really important to have tools that can detect routine, and then you can take action based on the rooted devices. And instrumentation tools. So these are very popular tools as well. So initially they were developed for researchers, security researchers, and developers. It helps them to test their app, but they're also used by attackers. So there is one popular one, it's called Frida. There are others as well. And it's very useful because it has custom scripts that you can use. You can see on the right, there are scripts for bypassing SSL certificates. There are scripts to bypass the routine detection. You can get the shared preferences, the data. Because with Frida instrumentation, you can do everything live. You can also tamper and change the behavior of the application at runtime. So you can know what the app is doing, and then you can modify the inputs and output. All right, so, and The last dynamic threat I want to talk about is malware. In fact, there is great evolution and sophistication of malware that are going on. Just in the past 3 years, malware has evolved to get more and more control. And I have a story about this bubble tea store. So there is a lady who went to the bubble tea store. They publicized that you can get a free bubble tea if you scan a QR code. So she scanned the QR code, brings her to a website to do a survey to get her bubble tea. She do the survey, download the app asks for permission, grant the permission, and then she used her device like normal. When she was sleeping, she wake up and then she saw that her bank account has been, empty. Why is that? Because the malware basically can do everything automatically. So the way it works is that when it asks for the accessibility permission, it's like an agent. It has access to the screen. It has access to the keyboard. And it's like a human who is typing your PIN. And it also have overlay screens. So for example, when you go to your bank account, you have UI, same as your bank account. You type your PIN. It will capture the PIN, and then it can replay everything later on to do the transaction. And then you will say, OK, but when I do transaction, I have the OTP that is coming on my bank. But the malware now can also get the OTP. So it can intercept the OTP, put the OTP, type it, and get the transaction happening. And a recent malware, we have analyzed some of recent one, and it can even get the lock of your screen, so the pin lock, the pattern. So the attack can happen even where device is locked, so you cannot see anything going on into the device. So it's really important to know that there are devices out there who are rooted, there are devices who have malware, who have risky apps. So when you do the development of your application, just take into account that when you do the development, it's not running on like a complete secure OS, like your environment. It will be running into a rooted device, and there are exploitation that are coming from the outside to target, if you are developing, for example, banking app, they will target a banking app, or they will exfiltrate some data. And so there is a need for the app to be aware of the environment. So the application needs to know what's going on in terms of the environment. And here, this is what we call AppSec observability. And the idea behind this is that you can, from your application, get a report on data. So when you develop the app, you release it, you still need to know what's going on after, where your app is running. Is it running on a routed device? Does it have a malware? Does this device getting tampered? Is your application getting tampered? And then you can take action based on this. So you have policies, and you can define the action based on this. Like, if I know that my app is running on a rooted device, I want to stop my application from running. So this is the AppSec observability, and this is really important to have, in my point of view, especially if you are dealing with sensitive data. All right, so protecting the data and keys. So as I said, a lot of customers, in fact, actually don't protect the data at rest. So it means that the data will be visible in the file system. And this is really important. You can see some examples here where you can get access to the database, SQLite database, and then you can extract very easily the data. There is something that exists, and it's been here for a while. It's called white box encryption or white box cryptography. And actually, traditional encryption, so let's say you want to encrypt some data. You will have your data, you will have your encryption key. So at some point, you need to provide your encryption key to perform the operation, right? And this is where the key can be attacked or can be extracted. With white box, so we do have a library that provides white box. It's used, for example, in the streaming to protect digital rights management, content video, or in the healthcare. And the idea with the white box is that the key and the algorithm are kind of mixed together, and an attacker will not be able to see the key even at runtime. So for example, when the application is performing the encryption key itself is not visible in the memory, even in memory or at rest. So that's very useful for specific use cases where you have a strong requirement to protecting the key. And that's my last slide, which is about the challenges and best security. So we have seen static attacks, dynamic attacks, and how we can protect also from malwares. And basically here, I put my favorite dessert here, which is a millefeuille. It's French dessert, and I love it. And security reminds me of this. It's like millefeuille means 1,000 leaves or 1,000 layer, and you don't need 1,000 to achieve the security. You just need some of them. And basically, the idea with security is that you need to have layers to protect against obfuscation, integrity checks, runtime detection, routing, instrumentation. And that's the idea behind the security. And there is the mobile app security verification standard from OWASP. I highly recommend you to have a look at it because it gives you an idea of basically what I've been talking here, but you can also do some practical exercises and to know what type of protection you can apply to your application. So I would summarize that security, it's all about a balance between the speed and security. You need to integrate the security from the beginning in your environments, not at the last at the last point. It needs to be integrated from the beginning inside your development cycle. And also need to make sure that it's a shared responsibility. There's not like one guy who is responsible for the security, because this one guy, maybe he don't know what needs to be protected. He don't know all the code. He don't know what is the sensitive data. So it should be a shared responsibility between all the different team members to try to understand and to know what are the risks, what are the threats that my app needs to be protected against. And then from there, we need to apply the security tools. And also, even when applying the security tools, sometimes you can have the best tools, but if you don't use them correctly, your app is still vulnerable. For example, if you don't protect resources using the tool, it's still someone can get the keys or anything from the resources. So it's really important to know what you want to protect and to protect it using the tool correctly. And as I said, is a shared responsibility between all the team members. And actually, if you want to get your app scanned, you can come visit us in our booth. We'll be happy to scan your apps and give you an idea of a report like this that can tell you all the findings. So we do binary scanning, and we give you an idea of the security finding related, for example, to OWASP or different standard. All right, thank you very much. I hope you like this talk, and looking forward to talk with you.